Hi everyone, here are your notes for section 4.4. I couldn't remember how I printed them out for those of you guys who have the skeletal notes in the giant packet. I'm not sure if I have this all together as one or combined or separated into two separate skeletal notes. So if that is the case, just kind of move through into both of them, but we're going to cover two new theorems today on proving triangles congruent. So far we have side, side, side. Now we're going to get into side, angle, side, and hypotenuse leg, HL. So our first thing that we have to make sure that we have covered is what's called the included angle. So if you look here, I have two sides, right? Top side, bottom side, and the angle that is created by those two sides is considered the included angle. So when we're talking about side, angle, side, the angle needs to be included or between the two sides that we're talking about for congruencies. Okay, so our side angle side theorem says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So, again, pause me as you need it. If this was triangle ABC, this was triangle D, really bad looking, DEF. And let's say side AB is congruent to side DE, and side BC is congruent to EF. Then the included angle on the left triangle would be B. So notice how side AB and side BC create that top angle. So that's the included angle, which would then match up with angle E on the other side. That would be the included angle. Notice that, that DE and FE create angle E. Okay. So you have that. I'm going to erase this for now. If for, actually no, come back. Let's do this really quickly. So we could then say, let's write our triangle congruent statement. Triangle ABC is congruent to triangle DEF, and in this case it would be by side, angle, side. Okay. Alright, so now I'm just going to play around and manipulate these triangles. So let's say my congruent side, first congruent side was here and here. Oh yeah, and I forgot, remember you can do like little S1s, since it's a single tick mark. And let's say we had my double tick marks here, so side 2, side 2. So I have two sets of congruent sides. Now my included angle would be this angle right here, matching up with this angle here. Or if I moved side 2 to the left and put it over here, then my included angle would be right here. See how it's in between? So hopefully you can kind of figure out where the included angle would be. So if my congruent sides were here, so if we go back to where we started, included sides are up top. So you have side 1, or side 2, matching up with side 2, 2 tick marks, side 1, 1 single tick mark, side 1, single tick mark, angle 1, because you only have one arc. Remember, we can have double arcs, triple arcs. So just kind of read it as you see it. Start at a corner, side, angle, side. Okay, so let's see if we can recognize side, angle, side. So determine whether the following triangles are congruent due to side, angle, side congruence. Write the congruent statement if so. So here, let's go ahead and write it out. I've got a single tick mark on AC, so I'm going to label that S1. Oops, in highlighter mode, S1. I got a single tick mark on EF, so S1, double tick marks, so S2, S2, and now I don't have a triple tick mark, so I don't have 3 sides, so I only have 2. I have a single arc on this angle and a single arc on this angle, so A1, A1. So I have 2 S's and an A, so now we need to decide, is that A between it? Is that A in front of it? We can't have bad words. No bad words in geometry class, so don't ever write that on a piece of paper. Can't have it behind it. That's just our bad words backwards, right? So what I need is that angle to be in between. So is it in between? Yeah, it's the included angle of my two sides. So it is side angle side. So we're going to say yes, they are congruent. My triangle congruent statement, I'm going to go triangle ABC, very original, is congruent to triangle. So A was the single arc, which would match up with E. B would be going from A to B is the double tick mark. So E to double tick mark would be to D. So B would match up with D, which would make C match up with F. By side angle side. Okay. All right, let's look at another one. So again, let's do our labeling. I think the labeling really helps. So look at your single tick marks, label them S1, S1, double tick marks, S2, S2, and that's all I got. I don't have any arcs in my triangles. I don't have another set of triple tick marks for side, side, side to be the case. But what you do have is, and we may always, always, always assume that vertical angles, here we have vertical angles, and remember vertical angles are congruent. So it is okay to assume that those vertical angles will always assume that they're congruent. So now I'm going to put a single arc there and call that A1, A1. So I have two S's and an A. Is it ASS? Or is it SSA? Or is it SAS? So let's decide if it is. So I have my side 2, side 1, included angle. Side 2, side 1, included angle. So I'm going to say yes. Triangle, I'm going to go DBA is congruent to triangle. So D is off of the single tick mark, which would match up with C. B matches up with itself. B, it's the reflexive property, and then E, by side angle side. Okay. All right. Let's look at C. I see single tick marks. So I got an S1 with an S1, S1 with an S1. I got an A1 and an A1. So I got two sets of S's and an A. Now we need to ask ourselves, is that A in between? So if I trace over the lines that are congruent, where they meet would be the included angle, which would be right here. That's not where that A1 is located. Same thing on this side. My included angle would be down here. That's not where my A is located. Kind of looks like Rudolph right there. So this would be a case of the ASS, which remember we cannot have. That's no good. So my answer is nope. They're not congruent by side angle side. Okay, so side angle side. Last one for side angle side before we get to hypotenuse leg. So we are given that RS is congruent to TK. You can see how there's the single tick marks there. What other information do you need to prove that triangle RSK, so triangle RSK is that one right there, is congruent to triangle TKS, which is that triangle down there. So I've got one set of sides. We need a second set of sides. And if you guys remember from our Desmos activity, where's that second set of sides? It's the one straight down the middle. That's because of the reflexive property. So there's my S2. So now I need an angle. Because we have a side. Now I need the angle. Where does that angle need to be? Well, if I trace side 1 and I trace side 2 of the top triangle, where do they meet? They meet up here at angle S. But I have two different angles occurring at angle S, so I need to be very specific with how I name that top angle. I want to name that angle 1, so I'm going to need to use all three letters. So I'm going to call this angle R to S down to K. So we need KS is congruent to itself. which in this case it's flipped, SK, right? SK matches up with KS. We need angle RSK, so that was that top angle 1 that I just had shown there. Now where's the other angle? Let's go down here. So S1 and S2 is the one across, so they meet down here at K, but it's this angle. So that's going to be congruent to angle TKS. So those are the other pieces of information we need to show congruency based off of side angle side. Okay, so hypotenuse leg. So before we get to hypotenuse leg, let's talk about right triangles and the vocabulary that comes with them. So the hypotenuse is the side opposite of the right angle in a right triangle. Okay, so down there in that right triangle, your hypotenuse is always opposite of the right angle. And then you have the leg, which is your other two sides of a right triangle. So we've got a hypotenuse, only one of them. It's always the longest side of your right triangle, and it's always opposite the right angle. And then your other two sides we just call legs. Okay, so hypotenuse leg theorem, otherwise known as HL, states the following. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Emphasis on the words right triangle. This only works when you have right triangles. So when you have a right triangle in front of you, that should be a red flag. Think, is it hypotenuse leg? It could potentially be a side angle side if the hypotenuse is not involved, but it most likely will be a hypotenuse leg if the hypotenuse is involved. Or it could be a no. So let's go ahead and sketch this out. I'm going to name this triangle A, B, C, D, E, F. Alright, so if a hypotenuse, my hypotenuse of the left triangle is BC, so if BC was congruent to the hypotenuse of another triangle, which would be EF, and a leg, so I can pick any leg, I'm going to go down here with AC, is congruent to DF, then we have enough information to say that my triangles are congruent. So then I could say triangle ABC is congruent to triangle A matches with D, B matches with E, C matches with F, E by hypotenuse leg. This is the only case where an angle side works, is with hypotenuse leg. Notice my angle is not the included angle. It's not where my sides that are congruent are meeting. It's over here. So it is a case of ASS, right? But we don't write ASS because it only works with right angles. So it's a hypotenuse leg. And it doesn't matter which leg it is. I can have it be the vertical leg. So this one and this one. That would also work for hypotenuse leg as long as the hypotenuse is involved. If the hypotenuse wasn't involved, and I had both legs, then it would be a side angle side. Okay. Alright, so let's go ahead and work through a few of these, and then we'll be done with our notes. So, looking to see if we have hypotenuse leg or not. If so, write a congruent statement. So here I do have right angles. Check. I have a hypotenuse with a hypotenuse. I have a leg with a leg. So yes. Triangle JKL is congruent to triangle J matches with M, K matches with N, and then O by HL. Let's go over to B. I have right angle, right angle. I don't know if you guys can hear my dog snoring or not. Is that loud enough? Maybe. I have a hypotenuse matching with a hypotenuse. Now where is the leg that is congruent? Well, this leg is not shown congruent to that leg, but straight down the middle, they share that leg reflexive property. So yes, triangle, I'm going to go ABC is congruent to triangle A matches with D. B in this case is the right angle on the left triangle, but C is the right angle on the right triangle. So it's going to be DCB by HL. Okay, hypotenuse leg. All right, so we're going to do some practice with this tomorrow. See you then.